Hello everyone. So in this video I'm going to talk about Newton's laws including friction. So we're going to focus on 5 areas and we'll do plenty of questions from these areas, and if you watch this video till end you will be able to answer one or two questions which can be asked from this chapter. Again, it's going to be a revision video, but we'll see application of each and every concept. So we're going to focus on these 5 areas: impulse, Newton's laws, constant relation, and then pseudo force concept, and then friction. And impulse I have already discussed in center of mass, right? So if you haven't watched that video, so kindly do so. So where I have discussed the basic concept about impulse and how to apply the impulse momentum theorem, right? So but still I'll discuss some of the problem based on impulse. So let us start with the very first problem types, that is impulse. A cricket player catches a ball of mass 120 grams moving with 25 meters per second speed. If the catching process is completed in 0.1 seconds, then the magnitude of the force exerted by the ball on the hand of the player will be. So here we know that the impulse is the change in linear momentum of the body. So the impulse which is being experienced by the person, or we can say it will be the same as the impulse experienced by the ball due to the person. So let us find the change in momentum of the ball. So it will be nothing but mass is 1.2 kilograms and the speed is 25. So we can say it is nothing but 3 Newton second, right? So that is the impulse. And we want to find and the time is also given. So once we know the impulse, if you divide impulse with the time duration, you will get the average force. So the average force will be 3 divided by 0.1, so it comes out to be 30 Newton. So option 4 is the right answer. Right, so let us do this question. A batsman hits back a ball of mass 0.4 kg straight in the direction of the bowler without changing its speed of 15 meters per second. The impulse imparted to the ball. So the ball just changes its direction after collision with the bat. So it was going in this direction, and after collision with the bat, it moves in the opposite direction. So what is the total change in linear momentum? It will be 2 times mu, where u is the speed. So that is the change in momentum, and we have to find the impulse. So that will be 2 times 0.4 times 15. So it comes out to be 12. So 12 Newton second is the answer. So do remember this. And I have discussed the same problem in center of mass one shot. Now let us see the next problem. A machine gun of mass 10 kg fires 20 grams bullet at a rate of 180 bullets per minute with a speed of 100 meters per second each. The recoil velocity of the gun, right? So the recoil velocity will keeps on increasing as long as the firing is happening, right? So it means they should also specify the time after what time we have to find the recoil velocity, right? So this question is not complete. So let me make it, let us find the recoil velocity after 1 second, right? After 1 second when the firing begins. So after 1 second, how many bullets are fired? So 180 bullets are being fired in 1 minute. So it will be 180 divided by 60. So that will give us number of bullets fired per second. So 3 bullets fired per second, right? So if this is the gun and 3 bullets are fired, so the linear momentum of this system must be conserved, right? And the bullets are moving with the velocity of 100 meters per second each. So the linear momentum of this system must be conserved. So we can say the linear momentum of the gun plus the 3 times the linear momentum of one bullet should be 0, right? Before firing and after firing. So we can conserve this. So we can say linear momentum of the gun, its magnitude will be 3 times the magnitude of one bullet. So it will be 3 times mass of one bullet, which is 0.02, and the velocity is 100. And linear momentum of the gun will be mass of the gun, that is 10, then the recoil velocity of the gun. So V will be, so this will be 6 by 10, which comes out to be 0.6. So basically they want us to find the recoil velocity after 1 second. So if the question is incomplete, always try to find it is this type of question in 1 second, right? So the option will be 4. A body of mass 5 kg is moving with a momentum of 10 kilogram meter per second. Now a force of 2 Newton acts on the body. in the direction of its motion for 5 seconds. The increase in the kinetic energy. So there is a body which is moving, which is having a momentum of 10 kilogram meter per second. So what is the velocity? So initial velocity will be momentum upon mass, which will be 10 divided by 5, which will be 2 meters per second. Right? So what is happening due to this force? It is acting for 5 seconds. So what is the impulse delivered by this force? It will be force times the time, which will be 10 Newton second. Now this momentum will increase the momentum. So we can say P2 minus P1. P2 we can calculate, P1 is 10 and this is 10. So P2 will become 20 Newton second. And we have to find the increase in kinetic energy. So increase in kinetic energy will be K2 minus K1, and K2 can be written as P2 square by 2m, and K1 can be written as P1 square by 2m. So it will be 1 by 2m, that is 1 by 2 times mass is 5. P2 square is 400 and P1 square is 100, right? So this is 10, so we'll get 30. So 30 joules is the increase in the kinetic energy. Now let us see this problem. So we have given 4 graphs, A, B, C, D, shows variation of force with time, and we have to find, and the impulse is highest in figure. So we have to find the impulse, right? And we know impulse is nothing but the area under force time graph. So integral f dt from t1 to t2. So this will give us impulse. So in the first case, force is being acted for 1 second. So we can find the area. So this area will be half, base is 1, height is 0.5, so which comes out to be 1 by 4 Newton second. In this case, the area, it's a rectangle, so it will be 0.5 times 2, which will be 1 Newton second. In this case, again it's a triangle, so half, base is 1, height is 0.75, so it comes out to be 0.375 Newton second. Now in the fourth case, the area will be half, base is 2, height is 0.5, so it will be 0.5 Newton second. So we can clearly see that in figure B we will get the maximum impulse. So option 2 is the right answer. Can you see the same question they have asked in the year 2021? So this question they have asked in 2021, and this question they have asked in 2023. So there can be repetition of the same question in future shifts. So that's why it is very important for you to practice PYQs, at least last 5 years PYQs. Right, so now let us see this question. A spherical body of mass 2 kg starts from rest, acquires kinetic energy of 10,000 joules at the end of 5th second. The force acted on the body. So again, we know that for the impulse, kinetic energy is given. So can we find the linear momentum? So momentum will be P square by 2m will be the kinetic energy. So P will be root of 2 mk. Mass is 2 kg and the kinetic energy is 10,000. So which comes out to be 200. So 200 Newton second is the linear momentum. So impulse is defined as change in linear momentum, so P2 minus P1, and the body starts from rest, so the initial momentum will be 0. P2 will be 200. Impulse will be force multiplied with the time, which is 5, because after 5th second the kinetic energy is 10,000. So F comes out to be 40 Newton. Right, so let us see the next area which we have to focus is Newton's laws. So a body of mass 4 kg experiences two forces, F1 and F2, the acceleration of the body. So according to Newton's second law, the acceleration is defined as net force upon mass of the system. So here net force will be F1 plus F2 divided by mass of the body. So F1 plus F2 will be 8 I cap plus 4 J cap plus 4 K cap, and mass is given as 4. So this comes out to be 2 I cap plus J cap plus K cap. So option 3 is the right answer. Right, so let us say this problem where we have blocks connected with string, and all the strings are light. three blocks A, B, and C are pulled on the horizontal smooth surface by the force of 80 Newton. The tension T1 and T2 in the string are. So whenever we have a system and all the constant of the system are moving with the same acceleration, we can consider it as a single unit. So if I consider this as a single unit, then the tension T1 and T2 will become internal to the system. So we can say we have a system of mass 5 plus 3 plus 2, and we are exerting an external force of 80 Newton in the right direction. So we can find the common acceleration. So acceleration will be at 80 net force divided by the mass of the system, which is 5 plus 3 plus 2, and it comes out to be 80 by 10 or 8 meters per second square. Now we got the acceleration for the system. So each constituent of the system must be moving with the same acceleration. Now you can consider subsystem. So if I consider 5 kg as my system, in that case, if I draw free body diagram of this, tension is always away from the object. So T1 is acting in the right direction. There will be a normal reaction on this body. There will be a gravitational force. And we have a horizontal surface, so there will be no frictional force. So we can say in the horizontal direction, we have the tension is acting in the horizontal direction, and the acceleration is 8 meters per second square. So we can say T1 is equals to mass times acceleration. Mass is 5, acceleration is 8. So T1 comes out to be 40 Newton. Similarly, if you consider 2 kg as your subsystem, then on 2 kg there is an external force of 80 Newton acting in the right direction, and tension is always away from the object. T2 is acting in the left direction, and this block has an acceleration of 8 meters per second square. So the net force in the direction of acceleration is 80 minus T2, which is equals to mass times the acceleration. Mass is 2, acceleration is 8. So T2 comes out to be 80 minus 16, so that will be 64 Newton. So option 1 is the right answer. Now let us see this concept. This arrangement is known as Atwood machine. And in Atwood machine, let us say M2 is heavier. It will go down with an acceleration A, M1 will go up with an acceleration A, and if you have a light string, the tension will be same everywhere. Let us say the tension is T. So you should remember the result. Acceleration will be given as m2 minus m1 upon m2 plus m1 times g, and the tension in the string will be given as 2 times m1 m2 upon m2 plus m1 times g, and we have to find the ratio of the masses, and acceleration is given to us, so we're going to use this formula. Acceleration is given as g by 8, so m2 minus m1 upon m2 plus m1 times g. So g will get cancelled out. So we can say m2 plus m1 upon m2 minus m1 will be 8 by 1. Now we can use componendo dividendo. So it will be m2 plus m1 plus m2 minus m1 divided by m2 plus m1 minus m2 plus m1. That will be 8 plus 1 divided by 8 minus 1. So m1 will get cancelled out, m2 will get cancelled out. So we will get 2m2 upon 2m1, which is nothing but m2 by m1, and it comes out to be 9 by 7, and we have to find the ratio of masses, so it will be 9 raised to 7. So option 1 is the right answer. Now let's see this problem. A wooden block initially at rest on the ground is pushed by a force which is increasing linearly with time. So here there is a block and we are exerting a force, and force is increasing linearly with time, so we can say it will be kt, where k is a constant. And now we have to form a acceleration time graph. So we can say acceleration will be f divided by mass of the body, which will be k by m times t. So a is also a straight line. The graph for acceleration time graph will be a straight line passing through the origin. So option 4 is the right answer. Now let us see this question. A wooden block of mass 5 kg rests on a soft horizontal surface. So there is a soft horizontal surface and there is a 5 kg block resting over it. When an iron cylinder of mass 25 kg is placed on the top of the block, the floor yields and the block and the cylinder together go down with an acceleration of 0.1 meters per second square. The action force on the system action force of the system on the floor Right, so if we place a cylinder of mass 25 kilograms over it, the floor yields, and this system starts accelerating in the downward direction with 0.1 meters per second square. Now let us see the forces acting on this system. So there will be a normal contact force in the upward direction, and there will be a gravitational force on the system. Total mass of the system is 5 plus 2 30, so it will be 30 g. So the net force, now we can apply Newton's second law. The net force in the direction of acceleration, which is in the downward direction, is 30 g minus n, and that should be equals to mass of the system times the acceleration. So from this we can find the normal reaction exerted by the floor on the system, or by the system on the floor. So it will be 30 times 9.8 minus 3, right? So it will be 98 minus 1 times 3. So that will be 97 times 3, or it will be 291 Newton. So option 2 is the right answer. Now we have pulley, and there are multiple blocks and strings. So let us see how to approach such questions. 3 blocks M1, M2 and M3 having masses 4, 6 and 8 kilograms respectively are hanging from a smooth pulley using a rope 1, 2 and 3 shown in the figure. The tension in the rope 1 is T1 while they are moving upward with an acceleration of 2 meters per second square is okay, right? So we have to find the T1 tension, and we have given that this system, all these 3 blocks are moving in the upward direction with an acceleration of 2 meters per second square. So we want to find T1. So what we're going to do, I'm going to consider these 3 blocks as my system, right? So when I do that, T2 and T3 will become internal to the system, so we don't have to worry about T2 and T3, and T1 will be the external force. So if I show the forces acting on the system, we can say there will be a tension T1 which is acting in the upward direction, and there will be a gravitational force in the downward direction, which will be nothing but sum of the mass of the sum of the masses times g. So it will be 4 plus 6 plus 10 times g. And this system is accelerating in the upward direction with 2 meters per second square. So the net force in the direction of acceleration is T1 minus 4 plus 6 plus 10, that will be 20. So 20 times g, that is 10, equals to mass of the system, which is 20, and acceleration is 2. So T1 comes out to be 40 plus 200, so that will be 240 Newton. So 240 is the answer of this question. Now let us see this question. A light string passing over the smooth pulley, light pulley connects 2 blocks of mass M1 and M2, and the acceleration is g by root 2, the ratio of masses. We have done similar question. It is basically the Atwood machine they are talking about. So I'm keeping this as a homework. When you try to solve this, you will get option 2 as the answer. A body of weight 200 Newton is suspended from the tree branch through a chain of mass 10 kilogram. So there is a chain. Let us, this is a tree branch, and from this tree branch, with the help of a chain, from the through a chain of mass 10 kg. Let us say this chain has mass 10 kilogram, and a block of weight 200 Newton is suspended. The branch pulls the chain by the force of. So if you consider chain and the block as a system, on this system, let us say the force is acting. So there will be a gravitational force, which will be the mass of the, so that will be a mass weight experienced. So the weight of the chain will be 100, and it has 200, so it will be 300 Newton, right? That is the weight of chain and the block. And this system is in equilibrium, so there has to be a force exerted by the branch on the chain in the upward direction. So we can say this force will be nothing but 300 Newton. So option 3 is the right answer. Right, so again this question is based on Atwood machine. So I'm again keeping this question as a homework. So if you try to solve this, you will get option 4 as the answer. Right, so now let us see the next problem based on the same concept. A 1 kg mass is suspended from the ceiling by a rope of length 4 meter. A horizontal force F is applied at the midpoint of the rope so that the rope makes an angle of 45 degree with respect to the vertical axis as shown in the figure, the magnitude of the force. So here, if you look at this knot, right? So we are exerting a force at this particular point and the string makes an angle of 45 degree. So if you consider, since it is in equilibrium, if you draw free body diagram of A, so we can say in this portion, the tension will be 10 Newton, right? So here we'll be having 10 Newton. So let me show the forces. So there will be a tension 10 Newton in the downward direction and there will be tension T1 in this direction and we are exerting an external force F in the left direction. And we have to find the value of F, magnitude of F. So what we can do, we can split T1 in horizontal and vertical direction. So let me split it. So this component will be T1 sine 45, which is nothing but T1 by root 2. And this component will be T1 cos 45, which is T1 by root 2. Now this T1 by root 2 will balance 10 Newton and this T1 by root 2 will balance F. So we can say F is equals to 10. So option 1 is the right answer. Right, so let us see this question, which is based on the motion along the inclined plane. A block of mass 200 grams is kept stationary on a smooth inclined plane by applying a minimum horizontal force, which is root x. So we have to find the value of x. So we are exerting the minimum force. It means this block is not sliding, right? And there is no friction anywhere. So if you draw the free body diagram, let us see all the forces acting on the block. So there will be a gravitational force. So for the sake of easier calculation, I am taking G as 10. So this will become 0.2 times G, which is 2 Newton in the downward direction. Now this force has, we can resolve this force along the inclined plane and normal to the inclined plane. Apart from this, there is a normal reaction also. Right? So now let me draw the free body diagram by resolving the forces. So there will be weight component down the incline. So this will be 2 sine 60. And there will be a weight component normal to the incline, which is 2 cos 60 degrees. And there will be the external force F, and let us take the component. So its component along the incline will be F cos 60. So this will be F cos 60 degree and its component normal to the inclined plane will be F sin 60. Apart from this, there will be a normal reaction which is normal to the inclined plane. And this block is in equilibrium, so we can say the forces which is along the inclined plane should balance each other and the forces which are normal to the inclined plane, they should balance each other. So from this we can say F cos 60 degree must be equals to 2 sin 60. So it will be F times 1 by 2 is equals to 2 times root 3 by 2. So from this F comes out to be root of 3 times 4, which will be root 12. So X is equals to 12. So 12 is the answer of this question. Right, so let us see this problem. A force on the object of mass 100 grams is 10 I cap plus 5 j cap. So we have given the force. So that is the force vector F. Mass is also given. The position of that object at t equals to 2 seconds is a I cap plus b j cap after starting from rest. We have to find the value of a by b. So position we have to calculate, we have given force. So we know that force can be written as mass times acceleration. Now this will give us the acceleration, right? So acceleration will be 10 I cap plus 5 j cap divided by mass, which is 0.1, or I can write this as 100 I cap plus 50 j cap. Now that is in meters per second square. Now we want to find the position and this acceleration is constant. So now we can apply kinematics. So position, we can say S can be given as, and I'm assuming it is starting from the origin, right? Initial velocity is 0. So half a t square. So this will be half 100 I cap plus 50 j cap. T is 2, so that will be 4. So this will give us 2. So it comes out to be 200 I cap plus 100 j gap. So we got the position, and where I component will be A and the j component will be B. So A by B we have to calculate, which comes out to be 200 by 100, which is 2. So 2 is the answer. Now let us see this question. A system of 10 balls, each of mass 2 kg, are connected via massless unstretched string, and the system is allowed to slip over the edge of the smooth table as shown in the figure. The tension on the string between the 7th and the 8th ball when 6th ball just leaves the table. So we have released the system when 3 balls were off the table, and we have to find the tension between 7th and 8th when 6th ball leaves the table. So let me redraw the diagram. So this will be 6th, 5th, 4th, 3rd, 2nd, and 1st, right? So 1, 2, 3, 4, 5, 6. And here we have 7th, 8th, 9th, and 10th, right? And each ball has a mass of 2 kilograms. So what is happening in this case? The weight of this portion is producing acceleration in this entire system along the string, right? So what we're going to do, so we can say what is the weight of this system, this portion. It will be 6 times mass of one ball times g, right? So that is the weight. So we can say it will be 12g is responsible for acceleration in this entire system. So it will be 10 times 2, that is the mass of the entire system, times the acceleration. So it means these 6 balls are going down and these 4 balls are going in the right direction with an acceleration a. So from this it comes out to be, this will be 6, so 0.6 g. So that is the acceleration. Now we have to find the tension between 7th and 8th ball. So what I'm going to do, since these balls which are on the table, they are moving with the same acceleration, so I'm going to consider a subsystem which has a boundary between 8th and 7th. So by doing that, the tension between 9th and 10th and 8th and 9th, this tension will be internal to the system. So we're left with only the tension between 7th and 8th. So on this system, we can say 10th, 9th, 8th. We have a tension T, and this system is accelerating in the forward direction with 0.6 g, and the mass of the system will be 2 times 3. So we can apply Newton's second law. So T is equals to mass times acceleration, so 0.6 times g. So it will be 3.6 times g, or if we take g as 10, it will be 36 Newton. So 36 is the answer. Right, so let us see this question. A mass of 10 kg is suspended vertically by a rope of length 5 meter from the roof. A force of 30 Newton is applied at the middle point of the rope in the horizontal direction. The angle made by upper half of the rope with the vertical is 10 inverse x times 10 raised to minus 1, the value of x. Now the similar question we have done, let me show you that question. This question is similar to that. Here the angle is given and we have to find the applied force, but here we have to find the angle and the force is given. So I'm keeping this as a homework, so try to solve this. If you try to solve this, you will get x as 3. Okay, so now let's see this question. A hanging mass m is connected to a 4 times bigger mass. So this is 4m, this is m. By using a string pulley arrangement as shown in the figure, the bigger mass is placed on a horizontal ice slab and being pulled by 2 mg force. So we are pulling it in the left direction with 2 mg. In this situation, tension in the string is x by 5 mg. We have to find the value of x. Neglect mass of the string and the friction of the block with the ice slab. So there is no friction, so it's a smooth surface. Ice, there is no friction between 4m and ice slab. So if the system is not moving, in that case we can say the tension in the string will be mg. So in that case, even right, but we are exerting a force of 2 mg in the left direction, so the system will accelerate in the left direction, right? So 4 m will go in the left direction with an acceleration a, m will go with an acceleration a in the upward direction. Now there are multiple ways to solve this question. What you can do, so one of the approach would be this 2 mg force will try to move the system in the left direction, and where is a gravitational force will try to resist the motion in that particular direction. So we can say the net pulling force will be 2 mg minus mg, and this should be equals to the mass times the acceleration of the system. So what is the total mass of the system? That will be 5m, and the acceleration is a, so this comes out to be mg divided by 5m. So acceleration comes out to be g by 5. So we got the acceleration, and we have to find the tension in the string. So what we can do, we can draw ABD of any block. Let us draw the ABD of M. So we have tension in the upward direction and gravitational force in the downward direction, and the acceleration is g by 5. So we can so the net force in the direction of acceleration is t minus mg, which is mass times the acceleration. So t will be 1 plus 1 by 5 times mg. So this comes out to be 6 by 5 mg, which is given as x by 5 mg. So x is 6. So 6 is the answer of this question. Right. So now let us this question for a free body diagram shown in the figure. The 4 forces are applied in x and y direction. What additional force must be applied and at what angle with the positive x-axis so that the net acceleration of the body is 0. So to have net acceleration to be 0, net force on the body should be 0. So what we can do, we have these 4 forces. So we can say we are exerting a force F5. If we add F5 to these forces, so let me call this as F1 plus F2 plus F3 plus F4, the resultant should be 0. So we can say F5 should be negative of the resultant of F1, F2, F3 and F4, right? So it will be opposite to the resultant of these 4 forces. So let us find the resultant. So we can say we have 7 in the upward direction, 8 in the downward direction. So we can say there is a 1 Newton in the downward direction, 6 Newton in the left direction, 5 Newton in the right direction. So there will be a 1 Newton in the left direction. So that is the resultant of these 2 forces will be root 2 Newton, because these are perpendicular. So this force, the resultant, so resultant of F1, 2, 3 and 4, it is in let me show this with this color. So it is in this direction, and this force is root 2 Newton. So we have to exert a force equal and opposite in the equal and opposite force in this direction. So that is F5. So F5 will be having magnitude same as root 2 Newton, and this angle will be 45 degree, because this angle is 45 degree. So root 2 times, so option A is the right answer. 4 forces are acting at a point P in equilibrium as shown in the figure. The ratio of the force F1 to F2. So we have to find the ratio of F1 and F2, and it is in equilibrium. So this point P is in equilibrium. So the net force must be 0. So what we're going to do, we'll resolve forces in horizontal and vertical direction. Right. So if I take the component of 2 Newton, so there will be a component of 2 by root 2 in this direction, and there is a component of 2 by root 2 in this direction. And then let us take the component of 1 Newton. So there will be a component of 1 by root 2 in this direction and 1 by root 2 in this direction. So the forces in the vertical direction should cancel out each other. So 2 by root 2 plus 1 by root 2 should be equals to F2. And in the horizontal direction, F1 plus 1 by root 2 should balance 2 by root 2. So this will give us 3 by root 2, and this will give us F1 as 1 by root 2. So we have to find the ratio. So F1 by F2 will be 1 by root 2 upon 3 by root 2, which is 1 by 3, which is given as 1 by x. So x will be equals to 3. So now let us see this question. A monkey of mass 50 kilograms climbs on a rope which can withstand a tension of 350 Newton. If the monkey initially climbs down with an acceleration of 4 meters per second square and then climbs up with an acceleration of 5 meters per second square, choose the correct option. So A, tension is 700 Newton while climbing upward, tension is 350 Newton while climbing down. Rope will break while climbing down, and rope will break while going down. Let us see. So there is a rope and there is a monkey which is climbing up and climbing down. So when it is climbing down, let us say, so what are all forces acting on the monkey? So there will be a tension in the upward direction and there will be a weight of the monkey which is 500 Newton in the downward direction. Quite heavy monkey, right? So now acceleration and the maximum tension that the string can bear is 350 Newton, and acceleration is given as climbing down with an acceleration of 4. So this is 4. Let us see how much tension is required. So the net force in the downward direction will be 500 minus t. That will be mass of the monkey times the acceleration. So t comes out to be 500 minus 200. So that comes out to be 300 Newton. So tension will be 300 Newton while climbing down. So that is incorrect. B is incorrect. Let us see the case when it is climbing up. When he was climbing up, so let us see the forces. So tension is in the upward direction, weight is 500 Newton in a downward direction, and it has an acceleration of 5 meters per second square in the upward direction. So the net force in the direction of acceleration is t minus 500, mass is 50, acceleration is 5, so t comes out to be 250 plus 500, so that will be 750. So it is 750, but the string can bear tension only up to 350 Newton, so the string will break in this case because this 750 is greater than 350. So A cannot be the right answer. So rope will break while climbing upwards. So C is the right answer. Now let us see the next question. Two inclined planes are placed as shown in the figure. A block A is projected from the point A of the inclined plane AB along its surface with a velocity just sufficient to carry it to the topmost point at a height of 10 meters. After reaching the point B, the block slides down on an inclined plane BC. The time it takes to reach the point C from the point A is t times root 2 plus 1. The value of t is. So while climbing up, it will be having a retardation, right? And the retardation will be g sine 45 degree, right? So we can find the time from A to B because we can find AB, and AB sine 45 will be 10. So we can say AB is 10 root 2. So we got the displacement from A to B, and the time from A to B we can calculate. So we can apply equations of motion. So let us apply second equation. So AB will be equals to, initial velocity is not given, but first let us find the initial velocity. Final velocity is 0, right? So we can say loss in gravitational potential energy, loss in kinetic energy will be equals to gain in gravitational potential energy. So we can say half mu square will be equals to mgh, and h is 10. So from this u comes out to be root of 2gh. So root of 2 times 10 times h will be 10. So it will be 10 root 2. So we got the initial velocity. So we can apply in the second equation. So s is equals to ut. That will be 10 root 2 times t minus half at square. A is 10 by root 2 t square, and AB is 10 root 2, right? So let us simplify this. So we have 10 root 2 is equals to 10 root 2 times t minus half 10 by root 2 t square, right? So let us multiply, let us first eliminate 10 from each term, and let us multiply with 2 root 2. So the left hand side will become 4, this will become 4 minus t square. So now we got a quadratic. So t square minus 4t plus 4, and which is nothing but t minus 2 square. So t comes out to be 2 seconds. So the block will take 2 seconds from A to B. Now it is sliding down, and let us, this length is L. So we can say L sine 30 degree will be 10 and that will be 20, right? So BC will be 20. So BC comes out to be 20, and it just reached the point B. So here the velocity will be 0 and it is coming down. So the acceleration will be G sine 30 degrees, right? So we got the acceleration. So and displacement we know, so we can apply the second equation. So it will be 20 is equals to 0 plus half G sine 30, that is 10 by 2, times T square. Let me call this as T1, this will be T2, right? So this 0 will get cancelled out. So we'll got T square as T2 as 2 root 2 seconds. So we got a T1 and T2. So we have to find T1 plus T2. So that will be 2 will be common, root 2 plus 1. So if we compare, this is given as T times root 2 plus 1. So T is 2. So 2 is the answer. Right, so now let us see this question. So we have given two bodies of mass m1 5 kg, mass is m1 5 kg and m2 is 3 kg, are connected by a light string going over a smooth light pulley on a smooth inclined plane as shown in the figure. The system is at rest. So it means both the blocks are at rest. The force exerted by the inclined plane on the body of mass m1. So the force which since it's a smooth surface, the only force which is exerted by m1 on the inclined plane will be normal reaction. So if I show the forces on m1, so we have normal reaction in this direction. Let me call this as n1. There will be a weight component which will be m1g cos theta, and there will be a weight component along the inclined plane which is m1g sin theta, right? So we can say tension will be equals to m1g sin theta, because tension is acting up the incline on this block. Similarly, tension is acting in the upward direction on m2 and the weight is in the downward direction. So this is also equals to m2 times g. So from this, since theta is not given to us and we want to find the force exerted by the block m1 on the inclined plane, so that force will be m1g cos theta, and theta is not given in the question, so we have to find the value of theta. So from this equation we can say sin theta is m2 by m1, and m2 is given as 3 and m1 is 5. So it is 3 by 5, and we know that at theta equals to 37 degree, sin 37 is 3 by 5 and cos 37 is 4 by 5. So m1 is 5, g is 10 times 4 by 5. So this comes out to be 40 Newton. So the answer will be 40. Option B is the right answer. Right, so let us see this question. Consider a frame that is made up of two thin massless rods AB and AC as shown in the figure. A vertical force P of magnitude 10 Newton is applied at the point A of the frame. Suppose the force is P resolved parallel to the arm AB and AC of the frame. The magnitude of the resolved components along the arm AC is x Newton, the value of x to the nearest integer. So we have to find the component of P along AC. So for that we need to find this angle, right? Let us say this angle is theta, right? So in this triangle, this angle is 45, so we can say this angle will be 35 because they are forming a linear pair. So 145 plus 35 is 180. Now 70 is the exterior angle for this triangle. So we can say this angle will be 25. Right, so this angle will be 25. 25 plus 35, sorry, it will be 35, not 25. This will be 35. 35 plus 35 will be 70. Exterior angle is sum of interior opposite angle. So if this is 35, then theta plus 35 will be 90. So theta will be it will be 30, 60, 55. Clear? So we got 35, 35, 70 and this angle will, oh right, so this is 35, not this is not 90. Theta plus 35 will be 70, right? These are alternate angles. So theta plus 35 will be 70 degrees, or theta will be 35 degrees. So the component of P vector along AC will be P cos 35 degrees, right? And what is P? P is 100. So this will be 100 cos 35. And cos 35 is given as 0.819. So it will be 81.9 Newton. So we have to round this to the nearest integers. The answer will be 82. So 82 is the answer of this question. Right. So let us say this question. The figure represents the momentum time graph for a particle moving along an axis under the influence of the force. Identify the region on the graph where the magnitude of the force is maximum and minimum respectively if T3 minus T2 is less than T1. So T3 minus T2, so this gap is less than T1, right? Right, so we have to find the force, and we know by Newton's second law, force is rate of change of linear momentum. So we can say it will be the slope to PT graph, right? It will be slope to this PT graph. So we have to check the slope, right? Magnitude. So more the steepness, we can say more the force. So here, and we have given T1 is less is greater than this length is greater than this length. So let me call this as y1, and let me call this as y2. So so the force Fa from in this region, right? In this region, force will be y2 divided by T1, and force in the third region will be y2 divided by T3 minus T2 in magnitude, if you want to find the magnitude. And we can clearly see that FB is less than FA, right? And if we compare FA and FC, this is y2, this is y1, sorry, not y2, this will be y1, right? T1 is greater, right? So T1 is greater, y1 is smaller than y2, so we can say FA will be less than FC, right? And we have given FA is greater than FB. Now from this we can say maximum and minimum. So it will be C and B, right? C and B should be the answer. So option 3 is the right answer. Okay, a block of root 3 kilogram is attached to a string whose other end is attached to the wall. An unknown force F is applied so that the string makes an angle of 30 degree with the wall. We have to find the tension. So here we have to consider equilibrium of this particular point. So in this case, this angle will be 30 degrees. And in this portion, the tension will be root 3 times G, that will be 10 root 3 Newton, right? So that is the tension. Force we have, and we have to find T. And force is also unknown to us. So tension is T. Now let us resolve tension in vertical and horizontal direction. So this component will be T cos 30 degrees, which is T root 3 by 2. And this component will be T sin 30, which is T by 2. Now F will be equals to T by 2, and T root 3 by 2 will be equals to 10 root 3. So root 3 will get cancelled, T will be 20 Newton. So, and we have to find tension only, right? So the option 1 is the right answer. Okay, let us see this question. Force acts for 20 seconds on a body of mass 20 kilogram. So there is a body of mass 20 kilograms, and we are exerting a force for 20 seconds. and it starts from rest. After which the force ceases and the body describes 50 meters in next 10 seconds. So after that, body cover 50 meters in 10 seconds. When there is no force acting on the body, it will keeps on moving with a uniform velocity. Let us that velocity is v. So we can say v will be distance upon time, which comes out to be 5 meters per second. So we can say due to the force, the body will acquire velocity of 5 meters per second, and we have to find the force, right? So we know that force is acting for 20 seconds, and if it is a constant force, we can say F times 20, that will be the impulse. And impulse, what it increases the linear momentum. So it will be mass times the increase in the velocity. So that will be 5 minus 0. So that comes out to be 100 by 20. So that will be 5 Newton. 5 Newton is the answer, right? So F comes out to be 5 Newton. Okay, at any instant, the velocity of the particle of mass 500 grams is 2t I cap plus 3t square j cap meters per second. So this is the instantaneous velocity. So v is given as 2t I cap plus 3t square j cap in SI units. If the force acting on the particle at t equals to 1 second is I cap plus x j cap, then what is the value of x? So what we're going to do, we'll differentiate this, we'll get the instantaneous acceleration. So instantaneous acceleration will be 2 I cap plus 60 j cap, and the force will be mass times the acceleration. So mass is given as 0.5, so it will become 0.5 times 2 I cap plus 60 j cap. So let us multiply this, so it will become 1 I cap plus 3t j cap, and force is given as I cap plus x j cap. So this is the force. So force at t equals to 1 second will be 1 I cap plus 3 j cap, which is given as I cap plus x j cap. So we can say x is 3. So 3 is the answer. So option 1 is the right answer. Right, so let us this question. A body of mass 500 grams moves along the x-axis such that its velocity varies with the displacement x according to the relation v is equals to 10 root x meters per second, the force acting on the body. So in order to find the force, we need to find the acceleration as per the Newton's second law. So let us find the acceleration. So dv by dt will be 10 times. The differentiation of root x will be 1 by 2 root x times dx by dt, where dx by dt is nothing but the instantaneous velocity. So it will comes out to be 5 by root x times v, and v is 10 root x. So root x will get cancelled out, so it comes out to be 50 meters per second square. So we got the acceleration. So the force will be mass times acceleration. Mass is 0.5 kilograms times the acceleration, so it comes out to be 25 Newton. So option 2 is the right answer. Right, so let us say this question. 3 forces F1, F2 and F3 are acting on a particle of mass 5 kg. The forces F2 and F3 are applied perpendicular so that the particle remains at rest. So we are right, so the particle is at rest and there are 3 forces acting. So it means the resultant of these 3 forces must be 0. So F2 and F3, they are acting in perpendicular direction. So F2 is 8 Newton and F3 is 6 Newton. So the resultant of these 2 forces will be root of 8 square plus 6 square, which comes out to be root of 100, which is 10. So 10 Newton is acting in this particular direction. So in order to keep this in equilibrium, F1 should act in the opposite direction, right? This will be F1, which is 10 Newton. If F1 is removed, then the acceleration of the particle is, so if F1 is removed, right, so in that case the resultant force on the system will be 10 Newton in the opposite direction. So 10 divided by the mass, that is 5, so it will be 2 meters per second square. So option 1 is the right answer. Right, so here we have given position vector at time t and the direction of net force applied by the particle. the direction of net force experienced by the particle. So again, we're going to find the acceleration, and if we multiply acceleration with the mass, we will get the direction of the force, right? Once we know the acceleration, we can find the force. So, and force is parallel to acceleration, right? So let us find the acceleration first. So R is given as 10t I cap plus 15t square j cap plus 7k cap. Let us differentiate this. So instantaneous velocity will be 10 I cap plus 30t j cap, and instantaneous acceleration will be 30 j cap. So we got acceleration, and this acceleration is in positive y direction. So the answer will be option 1, because force is parallel to acceleration. Right, let us say this question: a steel block of 10 kg rests on a horizontal floor shown. When 3 iron cylinders are placed on it, the block and the cylinder goes down with an acceleration of 0.2 meters per second square. So we have given an iron steel block, and we have placed 3 iron cylinder, right? The block and the cylinder go down with an acceleration of 0.2 meters per second. So they are going down with an acceleration of 0.2 meters per second square. The normal reaction R prime by the floor if the mass of the iron cylinder are equal and of 20 kg each. So this is 20, this is 20, this is 20, right? So, and the steel block is having a mass of 10. So overall, what is the mass of this system? That will be 20 times 3 plus 10. So it will be 70 kilograms. Now this 70 kilograms is going down with an acceleration 0.2 meters per second square. So let us see the forces acting on this system. So there will be a gravitational force which will be 70 G, right? And there will be a normal reaction exerted by the ground on the steel block. So let me just write it like this, and we have to find the normal reaction. So we can say 70 G minus N, that should be equals to mass of the system times the acceleration, right? Now from this we can find the value of N. So I'm taking G as 10, so it will be 700 minus 14. So this comes out to be 686 Newton. So there is no need of using the friction, because there is no relative slipping between the blocks. So we can just ignore this frictional coefficient of friction which is given in the question. So the answer will be option 2. A particle is projected with a velocity v0 along the x-axis. A damping force is acting on the particle which is proportional to the square of the distance from the origin. And we have given the force is minus alpha x square, the distance at which the particle stops. So we have given acceleration as minus alpha by m times x square. And we have to find the distance when the velocity becomes 0. So what we can do, we can write acceleration in terms of velocity and x. So we can write this as v dv by dx minus alpha by m x square, and from this v dv we have minus alpha by m x square dx. Now we can put the limits. So velocity is projected with a velocity v0. So the initial velocity is v0 when x is 0. Final velocity is 0 when x, and that we have to calculate, right? Let us say that is x0. So it will be v square by 2, and the limit will be from v0 to v0 to 0, and minus alpha by m, the integration of x square will be x cube by 3, and the limit will be from 0 to x0, and x0 we have to find. So this will be 0 minus v0 square by 2 equals to minus alpha by 3m times x0 cube. Now from this negative sign will get eliminated, so we'll get 3 by 2 m v0 square by alpha raised to power 1 by 3, so that will be x0. So if you look at the option 4, mass is also there, right? So mass is also coming in the picture, and we have to find the distance. Okay, and okay, right, so the distance, so mass should also come, so that should be the right answer. I think they have taken mass as 1 kilogram. So if you take it as 1 kilogram, then option 4 is the right answer. Right. Okay, a boy pushes a box of mass 2 kilogram with a force of 20 I plus 10 J cap on a frictionless surface. If the box was initially at rest, then what is the displacement along the x-axis after 10 seconds? So we have to find the displacement. And we are exerting this force. And right. So force, we have a constant force, right? So it must be having a constant acceleration. And we can find the displacement in 10 seconds. How we can do that? So acceleration will be F by m. So that will be 20 I cap plus 10 J cap divided by 2. So that will be 10 I cap plus 5 J cap. So we got the acceleration in SI unit, and we have to find the displacement in 10 seconds. So initial velocity is 0. So S is equals to ut plus half at square we can apply. U is 0. Acceleration is 10 I cap plus 5 J cap, and time is given as 10. So 10 square. So it will be 50 times 10 I cap plus 5 J cap. And we have to find the displacement. So it is nothing but the magnitude of this. So 50 times root of 100 plus 25. So 50 and we have to find, we have to find the displacement in the x direction. Right, so we got the position, right? So it is at 500 I cap plus 250 J cap. So if I show you on the graph or on the diagram, this is the origin, this is the x-axis, this is the y-axis. It started from the origin and somewhere it reaches here, which is having coordinates 500 comma 250. So its displacement along the x-axis will be 500, right? So 500 is the answer. Okay, let us see this question. As per the given figure, a weightless pulley P is attached on a double inclined frictionless surface. The tension in the string. Right, so in these questions, first we have to check whether there will be an acceleration or not. So how to check that? Let us see the net pulling force. So there will be a weight component in this direction, which will be 40 sine 60 degree, and there is a weight component in this direction, which will be 10 sine 30 degree. So this 40 sine 60 will be 20 root 3 and 10 sine 30 will be 5. So can you see 20 root 3 is greater than 5. So the system will go in this direction. So it will be having an acceleration A. It will be having an acceleration A up the incline. So the net pulling force, so the acceleration of the system will be the net pulling force, which will be 20 root 3 minus 5 divided by mass of the system. So 4 plus 1. So this comes out to be 5 will be common. So 4 root 3 minus 1 divided by 5. So we got the acceleration and we have to find the tension. Now we can draw free body diagram of any block. Let's draw the free body diagram of 4 kg. So there is a weight component of 20 root 3 down the incline. There is a tension up the incline. Normal reaction and weight component normal to the incline. We don't have to worry about that because we're going to apply Newton's second law down the incline. So acceleration we have calculated. So we can say net force down the incline will be 20 root 3 minus t. Mass of this block is 4 and the acceleration is 4 root 3 minus 1. Now from this we have to find the tension. So 20 root 3 minus 16 root 3 plus 4 is equals to t. So that comes out to be 4 root 3 plus 4. So tension comes out to be root 3 plus 1 times 4. So option 2 is the right answer. Right, so let us see this question. Two masses m1 and m2 are tied together at the end of a light inextensible string and passes over the frictionless pulley. When the mass m2 is twice of m1, acceleration of the system is a1, and when mass m2 is thrice of, again it is based on Atwood machine, so I'm not going to cover this. So I'm keeping this as a homework. Try to solve this by yourself. If you try to solve this option B, you will get option B as the answer. right? So the next problem, the area that we have to consider is constraint relation. So in this, when the pulley is moving, then what we can do, right? So let us see. All surfaces shown in the figure are assumed to be frictionless and the pulley and the string are light. The acceleration of the block of mass 2 kg is. So here this pulley is going, this pulley will be moving, right? So what we can say, first of all, let us see the tension. So we have tension T, here we have tension T, in here we'll be having tension T. Okay, so if I assume that 2 kg is going up the incline with an acceleration A, right? So we can say this point will go down with an acceleration A. This point will not move at all because this string is connected to a fixed support. So here acceleration will be 0. Now we're going to apply pulley constraint. So if the pulley is moving, let's say we have a center of the pulley which is going down with an acceleration AP, and this is the string, and this point have acceleration say A1 and A2, then AP can be written as A1 plus A2 by 2. So if I apply this constraint, let us say this center is going down with B. So A plus 0 by 2 will be equals to B. So the acceleration of 4 kg will be A by 2. So it is going down with A by 2. So if I draw free body diagram of 2 kg, so there will be a tension T up the incline, there is a weight component down the incline which will be 2g sine 30, and normal component will be there, normal reaction, and the weight component normal to the inclined plane will be there, but we are considered only with the forces which is along the incline. So it comes out to be T minus 2g sine 30 degree is equals to mass times the acceleration. So this is first equation. Now let us draw free body diagram of 4 kg. On 4 kg there is a tension. So if you consider this pulley, in this portion the tension will be 2T, right? Because this pulley is massless, so the net force on this pulley must be 0. So here we have tension T, here we have tension T, so this should be 2T, right? So here we'll be having tension 2T, weight 4G, acceleration is in the downward direction which is A by 2. So we can say 4G minus 2T is equals to 4 times A by 2. So this comes out to be 2A. Or we can say 2G minus T is equals to A. So we got another equation, right? Now what we can do, we can add these two equations. So if we add these two equations, T will get eliminated. So we'll get 2G 1 minus sine 30 degrees is equals to 3A. And this will be 2G 1 minus 1 by 2 is equals to 3A, or we can say G by 3 is A, right? And we have to find the acceleration of 2 kg, which is G by 3. So option 2 is the right answer. Right, so let us in this case, in the arrangement shown in the figure, A1, A2, A3 and A4 are the acceleration of the masses M1, M2, M3, M4 respectively. Which of the following relation is true for this arrangement? So where accelerations are given, let us say M1 is having an acceleration, say A1 in the upward direction, it is having an acceleration A2 in the upward direction, it is having an acceleration A3 in the upward direction, and A4 in the upward direction, and these accelerations are in ground frame. So it means if M1 is going up with A1, then this point must be going down with A1, right? Now again I'm going to apply pulley constraint. So let us find the acceleration of this point. Let me call this as this point as A, right? So in this case, if I consider upward as positive, so we can say A2 plus acceleration of A divided by 2 will be minus A1, right? Because A1 is in the downward direction. So from this, A comes out to be this comes out to be minus 2A. So what I have considered upward as, okay, let us we have taken upward as positive, so it will be minus 2A1 minus A2, right? So we got the acceleration of A. Now again we are considering upward as positive, right? So it will be acceleration of A, and we are getting acceleration of A as negative, right? It is minus of 2a1 plus a2. What does it mean? It means the point A is going in the downward direction. So it has an acceleration of 2a1 plus a2, right? Right. So let us again apply the pulley constraint for this pulley. So we can, let us take upward as positive. So it will be a3 plus a4 by 2 will be equals to minus of 2a1 plus a2. So from this we can say 4 times a1 plus 2 times a2 plus a3 plus a4 must be 0, right? So option A is the right answer. Right, so now let us see the new area, which is pseudo force. So let us see what is this concept. So whenever we are working in a frame which is accelerating, so to make that frame inertial, we have to exert a fictitious force which is called pseudo force, and it will be, for example, if there is a cabin and there is a pendulum, right? Or let us say there is a block, and this cabin is going in the right direction with an acceleration a naught. And if I want to study the motion of this block with respect to this cabin which is accelerating, which is a non-inertial frame, then I have to exert a pseudo force which is mass times the acceleration of the frame, and its direction will be opposite to the acceleration. So this force we have to exert, and when we exert this force, we'll be able to apply Newton's laws. Otherwise we cannot apply. Now let us say this question: a block A takes 2 seconds to slide down a frictionless inclined plane of length L, kept inside a lift going up with a uniform velocity V. If the incline is changed to 45, so let me just show you the initial situation. This angle is 30 degrees and there is a block, and this length is L, and this incline is going up with a velocity V, with a uniform velocity. So if I consider this problem with respect to this moving cabin, with respect to this observer, right? Now this observer is not accelerating, it is moving with a uniform velocity. So we can say this frame with respect to this observer, this frame is inertial. So we can apply Newton's laws. So we can say with respect to this frame, this block will be at rest initially, and it will be having an acceleration of g sine 30 degrees. So no need to apply pseudo force because the frame is not accelerating. So it is g sine 30 degree. So the time it takes, so we can apply Newton's second law, or we can apply the second equation of kinematics. So L will be equals to half g sine 30 t square, or let me call this as t1 square, right? So from this 2L upon g sine 30 root of that, so this will be t1. Similarly, for the the second case, if the incline is changed to 45, so if we change the incline to 45, in that case the time will be root of 2L upon g sine 45. So t2 by t1 will be equals to root of sine 30 by sine 45. So T2 we have to calculate. T1 is 2 seconds and sine 30 is 1 by 2 and sine 45 is root 2, 1 by root 2. So this comes out to be 1 by 2, right? So this will become 2 raised to power 1 by 4 multiplied with 2. So that is T2. Or we can write T2 as 2 raised to power 1 minus 1 by 4, which is 2 raised to power 3 by 4. Or we can write this as 8 raised to power 1 by 4, right? Or so when we simplify this, so this comes out to be close to 1.68, right? So if you take the, so 1.68 raised to power 4 will give us nearly 8. So 1.68 is the answer. So option C is the right answer. Right, so let us see the next question based on pseudo force. So 3 masses, M is 100 kilograms, M1 is 10 kilograms, and M2 is 20 kilograms, are arranged on a system. As shown in the figure, all the surfaces are frictionless and strings are inextensible and weightless. The pulleys are also weightless and frictionless. A force F is applied on the system so that the mass M2 moves up. It moves up with an acceleration of 2 meters per second square. The value of F is, so here it is moving up. So let me, so when we apply force on 100 kilograms, then this M2, it will comes in contact with capital M, right? So let me show all the forces acting on M2. So this is capital M, and this will be M2, and here we have a pulley. Right, so M1 is 10 kilogram, M2 is 20 kilograms, and capital M is 100 kilograms. And we are exerting a force F in this direction. So that the, right, and we have given acceleration of M2. So with respect to this block, it is going up with an acceleration of 2 meters per second square. So if it is going up with 2 meters per second square, we can say it is going in the left direction with 2 meters per second square. So we have to find the value of F. Right, so let me first draw the diagram of ABD of capital M. So on this, there will be a tension force which is T and T in this direction. There will be a normal reaction force. Let me call this as N2. There will be a normal reaction force N1 in this direction, and there is an external force F. Now these forces are acting, and it will be having an acceleration of, let us say, A in the right direction. So from this we can say F minus T minus N2 will be mass of this, which is 100 times the acceleration. So we got this is the first equation. Now what is N2? So let us draw the free body diagram of M2. So there will be a normal reaction N2 in the right direction, tension in the upward direction, weight in the downward direction, which will be 20 G. And if we study this block with respect to capital M, we have to exert a pseudo force which will be in the left direction. So that will be mass, that is 20 times the acceleration, which is A. And it is going up with an acceleration of 2 meters per second square. So from this we can say T minus 20 G, and G is given as 10, is equals to mass times the acceleration. So we got tension, which is 440 Newton. So we got tension, and N2 will be equals to 20 times A. So we got N2 in terms of A. Applied force we have to calculate. Now let us draw the free body diagram of M1. Right, so if you draw free body diagram of M1, if you study this with respect to capital M, it will be having a pseudo force in the left direction, which will be 10 times A, tension in the right direction, acceleration in the left direction. So it will be 10 A minus T, that will be 10 times the acceleration, which is 2. So tension we have calculated, it is 440. So it will be this will be 20. So tension is 440, so 10 times A will be 20 plus 440, so that will be 460. So acceleration will be 46 meters per second square. So we got the value of A, and we want to find F. Now from this equation we can say F will be T plus N2. T is 440 plus N2. N2 will be 20 times A, so 20 times 460. Let me again check. Tension is tension will be 240, not 440. It will be 240. It will be 240. So this comes out to be 260. So this will be 26. So A is 26. So 240 plus 20 times A, that is 260 plus 10, 100 times 260. So let us simplify this. So 240 plus 12, 5400. Right, so let me rewrite this. So we have tension is 240 and N2 will be 20 times A. So this will be 26, not 260. And then 100 times A. So 100 times A is 26. So this will be 520 plus 2600. So this comes out to be 760 plus 2600. So which comes out to be 0, 6, 13, 3360 Newton, right? So option A is the right answer. Right, so let us see this question. A person is standing in an elevator. In which situation he experiences weight loss? So when the normal reaction exerted by the floor on the person becomes 0, then he will feel weight loss. Let us see the option. When the elevator is moving up with a constant acceleration. So if the elevator is moving up with an acceleration a0, in that case the norm it will experience with the frame of the lift, the person will experience a pseudo force in the downward direction. So the normal reaction will become m times g plus a naught, which is non-zero, right? N is non-zero, so A is incorrect. When the elevator is moving down with a constant acceleration, when the elevator is moving out with a uniform velocity, and when the elevator is moving down with a uniform velocity. Let us see. So B, when the elevator is going down with a constant acceleration, let us say, let me call this as A1. So in this case, the normal reaction will be m times g minus A1, right? Now, if A1 is equals to g, in that case, normal reaction becomes 0 and the person will feel weightless. If A1 is equals to g, then n will become 0 and the person will feel weightless. If A1 is greater than g, in that case, normal reaction will again become 0 and the person with respect to the elevator will go in the upward direction with an acceleration. So this is the condition. So he will experience weightless only in this scenario when the elevator is going down with an acceleration. So B can be possible. Let us see C option. When the elevator moves up with a uniform velocity, when the elevator is moving uniformly, the normal reaction will be same as the weight in both the cases, right? Here the elevator is moving down with the uniform velocity. So C is not correct, D is not correct. So B is the most appropriate answer for this question. So now let us see this the question based on pseudo force. A block of mass m placed inside a box descends vertically with an acceleration a. The block exerts a force equals to 1/4 of its weight on the floor of the box. The value of a will be. So let me first draw the diagram. So we're given a box and there is a block of mass m which is placed in it. And this box is descending down with an acceleration a, and it exerts a force of 1/4 of its weight on the floor. So it means the normal reaction experienced by this block will be mg by 4. So let me study this problem with respect to the accelerated box. So with respect to this observer is accelerating in the downward direction along with the box. So we can say it's a non-inertial frame. To make it inertial, we have to exert a pseudo force. So, and the direction of pseudo force will be opposite to the acceleration and its magnitude will be mass times the acceleration. So, let me draw the free body diagram of the block with respect to this observer. So, there will be a pseudo force in the upward direction, which will be m times a. There will be a normal reaction in the upward direction and there will be a weight mg. And with respect to this observer, the box is at rest. So, it is at rest. So, the forces should balance each other. So, normal reaction comes out to be mg minus ma, and this n is given as mg by 4 in the question. And we have to find the acceleration of the box. So, m will get cancelled out. So, a will be 1 minus 1 by 4 times g. So, which will be g by 4. Now, the same question can be solved in a ground frame. So, with respect to say this observer B, if I draw the free body diagram, so there will be a normal reaction and there will be a gravitational force, and it is accelerating in the downward direction with an acceleration a. So we can say mg minus n will be mass times the acceleration, where normal reaction is given as mg by 4. So mg minus mg by 4 is equals to ma. So this will also give us the same, sorry, this will be 3g by 4, right? So this will also give us 3g by 4. So option C should be the answer. Right, so let us see this question. A person standing on a spring balance inside a stationary lift measures 60 kilograms. The weight of that person, if the lift descends with a uniform downward acceleration of 1.8 meters per second square, will be. So we have to find answer in Newton. So there is a lift which is descending with an acceleration of 1.8 meters per second square. So there is a person, let us say it is standing on a weighing scale. Now if I draw a free body diagram, or let us observe this person with respect to this non-inertial frame, then we have to exert a pseudo force. So there will be a pseudo force in the upward direction, which will be mass, that is 60 times the acceleration. And there will be a normal reaction n, and there will be a gravitational force mg, which will be 60 times g, so 600 in the downward direction. So with respect to this observer, the person is at rest, so the forces should balance each other. So n plus 60 times 1.8 should be equals to 600, or we can say n will be equals to 600 minus 6 times 18. So this will be 108. So this comes out to be 492 Newton. So 492 is the answer. Now let us this question. Statement 1, an elevator can go up or down with uniform speed when its weight is balanced with the tension of its cable. So it says there is an elevator and there is a cable, and it is going up and down with a constant speed. So if the speed is constant, the net force on the elevator must be 0. So in this case, the tension in the string must be balancing the gravitational force experienced by the elevator. So statement 1 is correct. Now the statement 2 is force exerted by the floor of an elevator on the foot of the person standing on it is more than his weight when the elevator goes down with increasing speed. If the speed is increasing in the downward direction, we can say there is an acceleration in the downward direction. So in that case, if I show the forces acting on the person or the passenger, with respect to the non-inertial frame, we have to exert a pseudo force, which will be ma in the upward direction. There will be a normal reaction in the upward direction and weight in the downward direction. So normal reaction comes out to be mg minus ma. So it will be m times g minus a, which is less than mg, right? So the force exerted by the floor of the elevator on the foot of the person standing on it will be more. That is incorrect. So statement 2 is incorrect. So option 2 is the right answer. Right, so let us see this question. A block of mass 40 kilograms. Now we move to the next section where I am going to discuss illustrations based on friction. A block of mass 40 kilograms slides over a surface when a mass of 4 kg is suspended through an inextensible massless string passing over the frictionless pulley as shown in the figure. The coefficient of kinetic friction between the surface and the block is 0.02. The acceleration of the block. If you look at the options, all options are non-zero. It means the system has an acceleration. So it means the friction will be kinetic. So what is the kinetic friction? Let me find the value for that. So kinetic friction is experienced by 40 kg. And in this case, 4 kg will go down with an acceleration a, and 40 kg will go right with the acceleration a. So if I draw free body diagram of 40 kg, it will experience a normal reaction. There will be a gravitational force. G is given as 10. So the gravitational force will be 400 Newton. And the friction is always opposes the relative motion. Since the block is sliding in the right direction with respect to ground, the frictional force should act in the backward direction, in the left direction. So kinetic friction is acting, and kinetic friction is mu times the normal reaction. So here normal reaction will be 400 Newton. So it will be 0.02 times 400, so which comes out to be 8 Newton. So frictional force is 8 Newton, which is acting in the backward direction. And there will be a tension force in the right direction, and it is having an acceleration A. So we can apply Newton's second law in the horizontal direction. So T minus A, which is the net force in the direction of acceleration, will be equals to mass of the body times the acceleration. So that is the first equation. Now if I draw free body diagram of 4 kg, gravitational force is in the downward direction, which is 40 Newton. Tension force is in the upward direction, and it is accelerating in the downward direction. So if I apply Newton's second law in the downward direction, so 40 minus T is the net force. Mass is 4, acceleration is A. Now we got second equation. Now we have a pair of linear equations in two variables. So we can eliminate tension and we can find the acceleration. So let us add these two equations. So when we add these two equations, we'll get 40 minus 8 is equals to 44A. So it comes out to be 32 by 44. Or I can write this as 8 by 11. So 8 by 11 is the answer. So option D is the right answer. Right, so let us this question. It is again from friction. A block of mass capital M slides down in a rough inclined plane with a constant velocity. The angle made by the inclined plane with the horizontal is theta. The magnitude of the contact force will be. So let me first draw the diagram. So there is an inclined plane and this angle is theta, and there is a block, and this block is going down with a constant velocity. So if the velocity is constant, we can say the net force acting on the block must be 0. So there is a gravitational force which will be mg. There will be a normal reaction, right? Apart from this, there has to be a frictional force. It is sliding down, so the relative motion is down the incline. So the frictional force, kinetic frictional force, will act up the incline. So this will be mu times n, right? So since it is moving uniformly, what we can say, the net force along the inclined plane must be 0. So if I take the component of weight along the inclined plane and normal to inclined plane, so this component which is along the inclined plane, which is mg sine theta, should balance mu n, right? And mg cos theta should be equals to n. So normal reaction will be mg cos theta, and mg sine theta is equals to the kinetic frictional force, which is mu times n, which is mg cos theta. Now from this, right, so now we have to find the magnitude of the contact force. So what is the contact force exerted by the ground on the block? So the block is experience normal reaction and the frictional force, right? And frictional force is mg sine theta, and the normal reaction is mg cos theta. So it means what we can say, so it means the contact force experienced by the block due to the ground will be the resultant of these two forces. So F square plus n square root of that. So F is frictional force is mg sine theta, and normal reaction is mg cos theta. Now from this, mg will come out, so root of sine square theta plus cos square theta. So this comes out to be mg. I hope this is clear. So option A is the right answer. So if they ask the normal contact force, then in that case we have to find the n. Since they are asking about the contact force, they have not mentioned the word normal, so that's why we have found the resultant of frictional force and the normal force. Right, so let us see this question. Consider a block in the trolley system as shown in the figure. If the coefficient of kinetic friction between the trolley and the surface is 0.04, the acceleration of the system. So friction is given and all the options are non-zero, so it means the system is sliding, like this trolley is sliding over the surface. So what we can say, let us say the acceleration is in the downward direction, 6 kg is going down, 20 kg going in the right direction. When the trolley is sliding, the friction has to be kinetic. So kinetic friction is acting in the backward direction. So if I draw a free body diagram of the trolley, so there will be a tension force in the right direction, there will be a normal reaction and gravitational force. So since options are quite far apart, I am taking G as 10. So this will be 200 Newton in the downward direction. Frictional force is mu n. Mu is given as 0.04. So it will be 0.04 times the normal reaction, which is 200. So which comes out to be 8 Newton. And the acceleration is a in the right direction. Now the net force in the direction of acceleration is t minus 8, and that should be equals to mass times acceleration. Now that is our first equation. Now if I draw free body diagram of 6 kilograms, it will experience gravitational force of 60 Newton in the downward direction, tension is t in the upward direction, and acceleration is a in the downward direction. Now the net force in the direction of acceleration is 60 minus t, which is mass times the acceleration. So this is our second equation. Right, so now we have two equations, or I will say I have a pair of linear equations in two variables, and we need to find the acceleration. Now we can add 1 and 2, and we can eliminate tension. So when we add, we'll get 60 minus 8, so this will be 26 times a, or 52 by 26 will be the acceleration, which comes out to be 2 meters per second square. So 2 is the answer, so option 3 is the right answer. Now let us see this question. Given below are two statements. Statement 1, the limiting force of static friction. So limiting force of static friction, we know it is mu s times the normal reaction. Depends on the area of contact and independent of the material. So it depends upon, it depends upon material also, because this mu, coefficient of static friction, it also depends upon the two surfaces which are in contact. So statement 1 is incorrect. Statement 2, the limiting force of kinetic friction is independent of the area of contact and depends on the material. Yes, because the kinetic frictional force is mu k times normal reaction. So it does not depends upon the area, it only depends what is the value of normal reaction. So mu k depends upon the two surfaces which are in contact. So statement 2 is correct. So statement 1 is incorrect, statement 2 is correct, so option 2 is the right answer. Right, so let us see this question. A block of mass m is placed on the surface having a vertical cross section given by y equals to x square by 4. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping. So here we have given a parabolic function. So let me first draw that. So this is y-axis, this is x-axis, and let us say this is our graph. Okay, I'm showing in the first quadrant, and there is a block, let us say it is at this particular position, and the coordinates for this particular point is x comma y, right? And it is not sliding, and it is so without slipping. So as we raise this block on this curve, then we can say the frictional force will keeps on increasing, and when it has the maximum height, then the friction will be limiting. So it means it will be having a tendency of sliding down. So the limiting friction will act in the tangential direction up the incline, right? So that will be our maximum friction, or you can say the limiting friction, which is nothing but mu times the normal reaction. Mu is given as 0.5. There will be a normal reaction. Apart from this, there will be weight, mg, right? This is normal reaction. So what we can do in this case, so if I draw a tangent at this particular point, let us say this angle is theta, then we can say this angle is also theta, right? So we can resolve. So what is tan theta? Tan theta can be written as dy by dx, and we have given the equation. So if you differentiate this with respect to x, if you differentiate y with respect to x, we'll get the slope, right? So it comes out to be 2x by 4, which will be x by 2. So we got the tan theta value at this particular position, right? And we have to find y coordinate, right? We have to find this height, which is nothing but the y coordinate. So we got tangent tan theta value x by 2. So in this case, the limiting friction must be balancing the weight component down the incline. So we can say mg sine theta must be balancing mu n, and n in this case will be mg cos theta. So from this, mg by mu mg will be equals to 1 by tan theta, and tan theta is 1 by tan theta is 2 by x. So we can say x will be 2 mu, right? Because mg will get cancelled out. So x will be 2 times mu, and mu is 0.5, so this comes out to be 2 times 0.5, so it will be 1. So we got x and we have to find y. So y will be 1 square by 4 by using this equation. So it comes out to be 0.25 or 1 by 4. So option 1 is the right answer. Right, so let us see this question. In the given arrangement of a doubly inclined plane, two blocks of mass capital M and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown. The coefficient of friction between the surface of the plane and the block is 0.25. So both the blocks, both the surfaces are rough and the coefficient of friction is 0.25. The value of m for which 10 kg capital M will move down with an acceleration of 2 meters per second square is. So we have to find the value of small m, and we have given capital M is going down with an acceleration of 2 meters per second square. Right, so in this case, as capital M goes down, there will be a kinetic frictional force. Let me call this as F1, and there will be a kinetic frictional force F2 experienced by M. Right, and there will be a weight component down the incline which will be capital Mg sine 53, and there will be a weight component down the incline experienced by small m which is Mg sine 37. Now what is the net pulling force in this case? We can say Mg sine 53 is trying to move this system down the incline on the left side, whereas F1, F2 and Mg sine 37 they are opposing it. So we can say the net force which is contributing towards acceleration will be Mg sine 53 minus F1 minus F2 minus small mg sine 37 degree, and that should be equals to mass of the system times the acceleration. Mass of the system is capital M plus small m times the acceleration is 2. So what is F1? F1 is mu, that will be 0.25 times the mg cos 53 degree, capital Mg cos 53 degree. Similarly, F2 will be 0.25 times small mg cos 37 degree. So let me substitute the value. Cos 53 is 3 by 5. So it will be 1 by 4 times mg times 3 by 5, and it comes out to be 3 by 20 mg. Similarly, cos 37 is 4 by 5. So 1 by 4 small mg times 4 by 5. So this comes out to be mg by 5. So we got frictional force. Let us substitute the value. Capital M is given. So in this equation, capital M is 10. G, we have to take 10. So this will become 100. Sine 53 is 4 by 5. F1 is 3 by 20 times capital Mg. Capital Mg is 100. Minus F2 is small mg. So that will be 2 times small m because G is 10. Minus m times 10, sine 37 is 3 by 5. Capital M is 10, small m we have to calculate times 2. So let us simplify this. So this will give us 2, this will give us 5, this will give us 20. So we will get 80 minus 15 minus 2m minus 6m is equals to 20 plus 2m. Now we will take m terms on one side and keeps the numerical values on the other side. So it will be 65 minus 20 is equals to 8 plus 2 times small m. So this will be 45 divided by 10. So m comes out to be 4.5 kilograms. So option 2 is the right answer. Right, so let us see this question. A block of mass 5 kg is placed on a rough inclined plane as shown in the figure. If F1 is the force required to just move the block up the inclined plane and F2 is the force required to just prevent the block from sliding down, then the value of the magnitude of F1 minus magnitude of F2 is, so we have to find the magnitude of this difference or the difference of these magnitudes. So what you have to remember here, the minimum will get the suppose we are exerting force up the incline. So the force will be minimum when this block has a tendency to slide down the incline. So when that is the case, then F minimum comes out to be mg sine 30 degrees minus mu mg cos 30 degrees. Now when and so the maximum force we will get the maximum force when this block has a tendency to slide up the incline. So in that case, maximum force will be given by mg sine 30 degree plus mu mg cos 30 degree. So we have given mass, coefficient of friction is also given. So let us substitute the value. So this comes out to be, mg will be common, so it will be 50. Sine 30 is 1 by 2 minus mu is 1 by 10. Cos 30 is root 3 by 2. And this comes out to be 50 times 1 by 2 plus root 3 by 20. So we have to take, so this will be the maximum force, this will be the minimum force. So here F1, force required to just move the block up the incline. So if it is moving up the incline, so basically F1 is maximum, right? And F2 will be minimum. So F max minus F min, if you take the difference of these two. So the first term will get cancelled out. So it will be 2 times 50 times root 3 by 20. So this will give us 5 root 3. So 5 root 3 is the answer of this question. Right, so let us see the next question. A 2 kg brick begins to slide over a surface which is inclined at an angle of 45 degree with respect to the horizontal. The coefficient of static friction between their surface is, so it is saying this angle is 45 degree and there is a brick which is having a mass of 2 kilograms and it begins to slide. It means the friction will be limiting. So there will be a weight component down the incline, that will be 2g sine 45, and there will be a weight component normal to the incline, that will be 2g cos 45 and normal reaction, and there will be a limiting friction which is mu times n. So when it is on the verge of sliding, 2g sine 45 must be balancing mu n. So n will be 2g cos 45 degrees. Now from this we can find mu. So 2g will get cancelled out. So mu comes out to be 10 times 45. So it will be nothing but 1. So option 4 is the right answer. Right, so let us see this question. A heavy box of mass 50 kg is moving on a horizontal surface. If the coefficient of kinetic friction between the box and the horizontal surface is 0.3, then the force of kinetic friction. Very basic question. So we have given a block, there will be a normal reaction and there will be a gravitational force which will be 50 times g, and frictional and the coefficient of frictional force, kinetic frictional force is 0.3. So Fk will be 0.3 times n, and n will be 50g. So which comes out to be 15 times 9.8, which is close to 150. So if you look at the option 2 is the right answer. Right, so let us see this question. A given object takes n times the time to slide down 45 degree rough inclined plane as it takes the time to slide down an identically perfectly smooth 45 degree inclined plane. The coefficient of kinetic friction between the object and the surface of the inclined plane is, so here we have given two inclined planes. This one is rough, 45 degree is given, and identical plane is given, but this one is smooth. And we are releasing a block from the top. So this block, let us say, takes time t1 and this block takes time t2 to reach bottom, and we have given n times the, so a given object takes n times the time to slide as it takes. So it is given as t1 is, sorry, t2 is a given object takes n times the time, okay, right. So t1 will be n times t2. So that is given to us in this question. So now we have to find the time taken by the block from in the first case and the second case. So in the first case there has to be a kinetic frictional force. So here acceleration will be G sine 45 degree minus mu G cos 45, right? Because there will be a frictional force of the incline. And in this case, the acceleration will be G sine 45 degree. And sine 45 and cos 45 is 1 by root 2. So let us find the time. So we're going to use S is equals to ut plus half at square. So we can say time will be given as 2 times the length of the inclined plane divided by G or acceleration, right? Root of that. So we can say T is inversely proportional to square root of the acceleration. So from this, T1 by T2 will be given as root of A2 by A1. And this is given as N. So root A2 by A1 will be G by root 2 upon G by root 2 will be common 1 minus mu. So G by root 2 will get cancelled out. Now we can square. So we'll get N square is equals to 1 upon 1 minus mu. And we have to find the value of mu. So mu 1 minus mu will be 1 by N square, or we can say mu will be 1 minus 1 by N square. So option 3 is the right answer. Right, so let us see this question. A uniform chain of 6 meters length is placed on a table such that a part of its length is hanging over the edge of the table. The system is at rest. The coefficient of static friction between the chain and the surface of the table is 0.5. The maximum length of the chain hanging from the table. So this is the table and there is a chain and some part of the chain is hanging. Something like this. Right, so in this case, which agent is responsible for this chain to slide down? It is the gravitational force experienced by the hanging part. Now the gravitational force experienced by the hanging part, it should balance the limiting frictional force experienced by the part which is on the table. So let me just highlight the part on the table. So this part. So we'll find the limiting frictional force experienced by this part on the table and equate that with the weight of the hanging part. Right, and what we have to calculate? So we have to find the maximum length of the chain hanging from the table. So let us say this length is x and total length is 6 meters. So we can say this portion on the table will be 6 minus x. So what is the frictional force experienced by 6 minus x length? It will be, so limiting frictional force will be mu times the weight of that, and we have given, let us say m is the mass of this length, m is the mass of 6 meters. So we can say m by 6, that is mass per unit length, times the length of the part on the table, which is 6 minus x, multiplied this with g. So that is the limiting frictional force. And what is the weight of hanging part? That will be mass of the hanging part, which will be m by 6 times the length, multiplied this with acceleration due to gravity. Now we have to equate these two, right? So mu m by 6, 6 minus x times g will be m by 6 times x times g. Now from this we can eliminate g, we can eliminate m, we can eliminate 6. So from this x comes out to be, okay, right, so we have mu, mu is given as 0.5. So from this we can say it will be 6 x upon 6 minus x will be equals to mu, which is 1 by 2. So from this 2x is equals to 6 minus x. So x comes out to be 2 meters. So 2 is the answer, right? Okay, so now we have two blocks problem. A system of two blocks of mass m, small m is 2 kg, capital M is 8 kg, is placed on a smooth table as shown in the figure. The coefficient of static friction between the two blocks is 0.5. So here we have mu s is 0.5. The maximum horizontal force capital F that can be applied to the block of mass capital M shows that both the blocks move together. when both these blocks move together, right? So which agent is responsible to produce acceleration in small m? It is the frictional force, right? So when both are moving together and we want to find the maximum value of f, in at that very instant, the friction between capital M and small m will be limiting, right? And if we increase f beyond that value, the friction will change into kinetic, right? And there will be a relative slipping between the two blocks. So here the condition is the friction will be limiting. So first let us find the common acceleration. So common acceleration will be F divided by capital M plus small m. Frictional force is internal to the system, so we don't have to worry about that. So it comes out to be F divided by M plus small m, that will be 10. Now if I draw free body diagram of small m, now this it will experience frictional force in the right direction. And this frictional force will be mu times small mg. It is a limiting frictional force and it has an acceleration of F by 10. So we can say mu mg will be equals to F by 10 times the mass of this small m. So small m will get cancelled out. Mu is given as 0.5, g I am taking as 9.8, and multiplied this with 10, it will give us the force. So it comes out to be 49 Newton. So option C is the right answer. Right, so let us see this question. A bag is gently dropped on a conveyor belt moving at a speed of 2 meters per second. So we have given a conveyor belt. And it is moving with a constant speed of 2 meters per second. The coefficient of friction between the conveyor belt and the bag is 0.4. Initially the bag slips. So if we drop a bag, its initial velocity was 0. So there will be a relative slipping between the conveyor belt and the bag. So what is the direction of slipping? So with respect to the conveyor belt, if you with respect to the conveyor belt, the bag is going in the backward direction, in the left direction, right? So it is going in the backward direction. So the frictional force must be acting in the forward direction, and this frictional force will be kinetic. And due to this frictional force, after some time, the bag will also acquire same velocity as the conveyor belt, and after that there will be no slipping between the bag and the conveyor belt, and it will keeps on moving with 2 meters per second. So what we can do, this frictional force will increase the kinetic energy of the bag. And what we have to calculate, the distance traveled by the bag on the belt during the slipping motion. So if I show the free body diagram of the bag, frictional force will be mu times mg, because normal reaction is n, gravitational force is mg. So mu mg, mu is given as 0.4, mass of the bag is not given, and g is given as 10. So that comes out to be 4m. So the acceleration which is being produced in the bag will be 4m divided by mass, which will be 4 meters per second square. And due to this acceleration, its velocity will increase from 0 to 2 meters per second. And we have to find the distance traveled. So we got the acceleration, we have to find the distance traveled, this we have to calculate. And final velocity we know, which is 2 meters per second, initial velocity is 0. So we can apply the third equation of motion. So v square is equals to u square plus 2as. So v will be 2, u will be 0, acceleration is 4, and from this we can find s. So 4 divided by 8, so which comes out to be 0.5 meters. So option B is the right answer. Right, so now let us see this question. A body of mass 1 kg rests on a horizontal floor with which it is having a coefficient of static friction 1 by root 3. It is desired to make the body move by applying the minimum possible force F. The value of F will be. So when we want, they ask about like what is the minimum force required. The force is not in the horizontal direction, it is always at a certain angle. So let us see. So there is a body of mass 1 kilogram and we are exerting a force, say at an angle. And why are we exerting force at a certain angle? Because with this force, it is having a vertically upward component which will reduce the normal reaction and it will decrease the maximum value of limiting friction. So we have this force F and this angle is theta, let us say. There will be a normal reaction. There will be gravitational force, G is 10, so that will be 10 Newton in the downward direction. And there will be limiting friction in the backward direction, which will be mu times N, right? So when we simplify this, or let me just quickly do the derivation. So here, this F will be having two components. This will be F cos theta, and this component will be F sin theta. So in the vertical direction, we can find the normal reaction, which will be 10 minus F sin theta. And in the horizontal direction, F cos theta must be balancing 1 by root 3 times the normal reaction, and normal reaction we can substitute from this equation. So that will be 10 minus F sin theta. Now from this we will get F as a function of theta. So let me so we can write F will be 10 by root 3 divided by cos theta plus sin theta by root 3, right? Now in the denominator we have cos theta plus sin theta by root 3. So if we are able to find the maximum value of the denominator, it will give us the minimum value of the frictional force, right? Or not frictional force, the applied force. So F will be minimum if cos theta plus sin theta by root 3 is maximum. So what is the maximum value of A cos theta plus B sin theta function? The maximum value is root of A square plus B square. So in this case, F minimum will be 10 by root 3 divided by maximum value of this, which will be root of 1 square plus 1 by root 3 square, because in this case A will be 1, B will be 1 by root 3. So that will be 10 by root 3 divided by root of 1 plus 1 by 3. So this comes out to be, so 10 by root 3 divided by 2 by root 3. So which is 5. So 5 is the answer of this question. Now let us see this question. A boy of mass 4 kg is standing on a piece of wood having mass 5 kg. So it is having a mass 5 kg. A boy has a mass of 4 kg. If the coefficient of friction between the wood and the floor is 0.5, the maximum force that the boy can exert on the rope so that the piece of wood does not move from its place, in Newton we have to calculate, and we have to round off the answer up to the nearest integer. Now in this case, they have not mentioned in which direction the person is pulling the string. They have shown that the string is making certain angle with the horizontal. Now if I draw free body diagram of the boy, right, so it is experiencing a tension in this particular direction, right, and we have to find the value of the pulling force such that this block is on the verge of sliding. Now for this particular person, there will be a normal reaction, there will be a weight, right? Apart from this, this person is also in equilibrium, so there has to be some frictional force. So this boy must be having some relative tendency to slide over the wooden piece. So for that, there has to be a frictional force in the left direction, right? And no information is given about the friction between the boy and the block. So what we can do, so we can assume that there is no tendency of slipping of the boy over the wooden block. So if there is no tendency of slipping, friction will be 0. So this tension must be acting in the vertically upward direction. So it means the person or the boy is pulling the string in the downward direction. So if we consider that assumption, so if I draw the free body diagram of the boy, so there will be a tension in the upward direction, there will be a normal reaction, and there will be a gravitational force which will be 40 Newton, right? And if I draw a free body diagram of the wooden block, there will be a tension in the right direction. There will be a normal reaction exerted by the boy. There will be a weight which will be 50 Newton, and there will be a normal reaction exerted by the ground. And there is a friction between the wooden block and the ground, so there will be a limiting friction in this direction which will be 0.5 times N1, where N1 is the normal reaction exerted by the ground on the block. So from the equilibrium of the buoy, N plus T must be equals to 40, or we can say N will be 40 minus T. And if we consider the wooden block in the vertical direction, we can say N plus 50 must be equals to N1. And in the horizontal direction, T must be equals to 0.5 times N1, and N1 is N plus 50. And N is 40 minus T. So 0.5, 40 minus T plus 50. So from this, we can say 2T is equals to 90 minus T. So T comes out to be 90 by 3. So that will be 30 Newton. And we have to find the maximum force that the buoy can exert. So the pulling force is same as the tension force. So this will be 30, right? So 30 is the answer of this question. Right, so let us see this question. A block of mass M slides along the floor while the force of magnitude F is applied to it at an angle of theta as shown in the figure. The coefficient of kinetic friction is mu k, then the block acceleration is given by. So in this case, in this question, if I draw the free body diagram, so there will be a normal reaction, there will be a gravitational force, there will be a kinetic friction in the backward direction, which is mu k times n. And this F we can resolve F in two components, F cos theta and F sin theta. So in the vertical direction, forces will balance each other. So normal reaction will be given as mg minus F sin theta. In the horizontal direction, acceleration is A. So we can say F cos theta minus mu k n, and n is this. So mg minus F sin theta, that will be equals to mass times the acceleration. Now we can divide throughout by m. So we will get this. So this will be F cos theta by m minus mu k times g minus F sin theta by m. So if you look at the option B or option 2, it is matching with our answer. So this is the answer. Right, so let us see this question. A block of mass m slides down a plane inclined at an angle of 30 degree with an acceleration g by 4, the value of coefficient of kinetic friction. So there is an inclined plane, this angle is given as 30 degree and it is sliding down and the acceleration is given as g by 4. So if I show the forces acting on the block, so there will be a weight component down the incline which will be mg sin 30. There will be a weight component which is normal to the inclined plane, mg cos 30 degree. There will be a normal reaction and there will be a kinetic friction up the incline which will be mu k times n. So down the incline, the net force will be mg sin 30 minus mu k times the normal reaction which is mg cos 30 degrees. So this comes out to be mass times the acceleration, and acceleration is g by 4. So m will get eliminated. So g by 2 minus mu k g root 3 by 2 is equals to g by 4. So let us take this 2 on the other side. So this will become g by 2. And we have to find the value of mu k. Now from this, g root 3 times mu k will be g minus g by 2. So g will also get eliminated. So mu k times root 3 will be 1 minus 1 by 2, or mu k comes out to be 1 by 2 by root 3, right? So option 2 is the right answer. Alright, so let us see this question. The time taken by an object to slide down 45-degree rough inclined plane is n times. We have done similar question, right? So I'm keeping this question as a homework. If you try to solve this, you will get option 4 as the answer. Alright, so let us see this question. Consider a block kept on the inclined plane. This angle is 45 degree as shown in the figure. If the force required to push it up the inclined plane is 2 times the force required to just prevent it from sliding down, the coefficient of friction. So we have done similar question, right, where we have discussed the maximum and the minimum force. So again, I'm keeping this as a homework. So if you try to solve this, you will get option 1 as the answer. Right, so let us see this question. Maximum horizontal force that can be applied on the larger block so that both the blocks move together. Again, similar question we have discussed. So again, I'm keeping this as a homework. If you try to solve this, you will get answer as 21 Newton. Right, so now let us see the next question. A body of mass m is launched up on a rough inclined plane making an angle of 30 degrees with the horizontal. The coefficient of friction between the body and the plane is root x by 5. If the time of ascent is half of the time of descent. So if the time of ascent is half of the time of descent, then the coefficient friction between the body and the inclined plane is root x by 5. We have to find the value of x. So let me first draw the diagram. So we have given an inclined plane and this angle is 30 degrees. And we are launching a body up the incline with certain velocity u, and it reaches the maximum height, say from A to B. Here the velocity becomes 0. Right? So, and let's say this distance is L. So time from A to B is half of time from B to A, right? And why there is a difference? Because the acceleration will be different from A to B and from B to A. Right, so here I'm going to use, so we can find the acceleration from A to B, and we'll also find the acceleration from B to A, and then we'll use the second equation of motion, where S is equals to u t plus half a t square. So and we know that V is equals to u plus at. So we can write if I multiply this with t, so we can write ut as Vt minus At square. So if I substitute in this equation, I will get S is equals to Vt and minus 1 plus, that will be minus 1 by 2 At square, right? So if I want to use second equation, keeping final velocity, I can use this relation, right? So in this case, the acceleration, retardation while going from A to B, let me call that retardation as A1. So it will be G sine 30. So as it is going up the incline, as the block is going up, in that case, friction will be acting down the incline, right? Friction is acting down the incline. And apart from this, weight component is also acting down the incline. So we can say the retardation will be G sine 30 plus mu G cos 30. So this comes out to be G 1 by 2 plus mu root 3 by 2. Similarly, if the block is coming down, if it is coming down, in that case the frictional force will be acting up the incline, weight component is acting down the incline. So while coming down, the acceleration will be G sine 30 minus mu G cos 30. So this can be written as G times 1 by 2 minus mu times root 3 by 2. So while going from A to B, I'm going to use this relation where we have V as the final velocity. So L, so I'm considering up the incline as positive, is equals to final velocity 0 minus half, acceleration is down the incline, so that will be negative, right? So minus of G 1 by 2 plus root 3 by 2 times mu times, let me call this as T1, right? T1 square. So from this, we are getting, so half is there, G is there, right? So let us take this 2 outside. So this will become G by 4, 1 plus root 3 mu times T1 square is equals to L. Similarly, if I use second equation from B to A, so initial velocity will be 0, right? So L comes out to be half, acceleration will be G by 2, 1 minus root 3 times mu T2 square. So this is T1 half of T2, right? So we have to find mu. Let us take the, let us equate these two equations. So we will get 1 minus root 3 mu times T2 square will be equals to 1 plus root 3 mu times T1 square. And T2 by T1 is equals to 2. So T2 by T1 is 2. So we can say 1 plus root 3 mu upon 1 minus root 3 mu is T2 by T1 square, which will be 4. Right? So now what we can do, we can use componendo and dividendo. So 1 plus root 3 mu plus 1 minus root 3 mu divided by 1 plus root 3 mu minus 1 plus root 3 mu, that will be 4 plus 1 upon 4 minus 1. So this will get cancelled out, this will get cancelled out. So we'll get 2 divided by 2 root 3 times mu, which is 5 by 3. 2 will get cancelled out. Or we can write root 3 mu is equals to 3 by 5, or we can take this root 3 on the other side and this will become root 3. So mu comes out to be root 3 by 5, which is given as root x by 5. So x will be 3, right? So here I conclude this video. So I try to keep it as brief as possible. So I have covered like the types which can be asked in JEE Mains 2025. So if you watch this video this end, I'm pretty sure you'll be able to answer 1 or 2 questions which can be asked from this chapter. If you find videos of this series useful, so it is highly recommended for you to join PracBee's revision program. So in this program, we're going to cover 10 blocks in 10 weeks, and we'll give you a target of 1 chapter per day, and we'll be able to cover all relevant chapters by the first attempt of JEE Mains. And how you can join this revision program? By clicking on the link given in the description. And one more thing you can do, please drop a comment. Let us know what else we can do for you to make this series better. Thank you.